Stan Gibilisco here to illustrate for you very quickly the difference between phase coincidence and phase opposition when you have sine waves of the same frequency. It's very important for the waves to have the same frequency in order for either of these terms to make any sense, because otherwise the phase will change from cycle to cycle and it screws everything up. So suppose that you have two waves, sine waves in these cases, that are lined up exactly with each other. The minimum occurs here for the weaker wave at the same place that the minimum occurs for the stronger wave. Same with the maxima, same with the 0 points. These are the relative phases of the waves: 0 degrees, 90 degrees a quarter of a cycle, 180 degrees a half a cycle, 270 degrees 3/4 of a cycle, 360 degrees and back to 0. Phase coincidence simply means that the two waves coincide in phase. They line up with each other exactly. Whereas in phase opposition, one wave is exactly upside down with respect to the other one. In this case, the weaker wave reaches its minimum when the stronger wave reaches its maximum, and the weaker wave reaches its maximum when the stronger wave reaches its minimum. They still both cross the 0 voltage point at the same place, the 180 degree marker in the cycle in this example, but you can easily see the difference. Phase coincidence, phase opposition. Now, phase opposition means they oppose in phase. One wave is exactly upside down with respect to the other. That is, in the case of sine waves, the same thing as a 180 degree phase shift. But with other waves, more complex waves, and in fact with most waves other than sine waves, phase opposition and phase coincidence do not behave the same way as a 180 degree phase shift. So when you hear someone calling phase opposition the same thing as a 180 degree phase shift, when you see or hear someone interchanging those two terms, they're looking at the situation too simplistically. It only applies to sine waves and triangular waves. I believe it also applies to, but only very specific types of waves. So phase opposition is not the same thing as a 180 degree phase shift most of the time, although it is in these cases. So phase coincidences, the two waves line up with each other. Phase opposition, one wave is exactly upside down with respect to the other one. At every point on the cycle, you have an equal distance, or I should say the positive and negative points coincide with each other in exact opposition, whereas here they coincide with each other in exact agreement. Do I make myself clear, or have I only confused you more? Well, sometimes on the planet Jupiter, things do get a little confusing, especially because the magnetic field on Jupiter produces radiation so strong that it would fry your brain cells so fast that you wouldn't even know what happened to you before you were dead. So I'm not really at the planet Jupiter, nor on any of its moons. I'm just showing you this because it's a cool image from Great Images in NASA, one of many images you can use as wallpaper from that site. Stan Gibilisco signing off for now. Until next lesson, so long.